नॉट स्पोकन अबाउट द कंस्ट्रेंट मोशन के अलावा कि हाउ द फोर्सेस वर्क, कितना जाता है, कैसे एक्सेलरेशन होता है. A quick recap I'm going to do and let me know if this part of board is visible. Okay, good. Okay, couple of things I want to recap to all of you over here. Tension in one string would remain same. Tension in one string will be same throughout. वो स्ट्रिंग कैसा कहीं भी है, अगर सिंगल स्ट्रिंग है बच्चों तो उसमें वो सेम रहेगा टेंशन थ्रू आउट. पहली बात तो है. दूसरी बात, स्प्रिंग के बारे में मैंने बताया था कल. yesterday I talked about the spring. Moment we cut in uncut spring, force doesn't change to zero immediately. ऐसे मैंने कल बता रखा है in the previous classes. Rahul, you there? Rahul, are you there? Can I hear you? I cannot hear you, Rahul. I cannot hear you. Yes. Now well and good. Okay, fine. Okay, so uncut spring, the force does not change to zero immediately. In string, force, or you can say tension. In string, tension may change to zero. Immediately based on the certain conditions that we're going to see in the many cases. We have seen in the one of the example yesterday. एक छोटा सा example. Let's understand what we are going to talk about. Let's suppose we have a pulley over here. With one rope, I have one mass. Let's suppose M. With another rope, I have another mass. Let's suppose 2M. Once I leave it freely, because of the heavier mass, because of the higher mass, this entire system would come down in this direction with certain acceleration. Okay, so let us suppose that acceleration this side is A. Now the same acceleration will be there for this block in the upward direction A. All good, all of you? Now there is going to be a force acting on this in the downward direction, that should be 2mg, and there should be a force acting on this, tension developed. Since the string is same, बच्चों string same है, so the same tension would come here, and there going to be a force, of course, weight of this block mg downward, and due to this tension, these string, like this block would have some acceleration. एक बात और बताता हूं. Since we have tension T here, so the same tension should pull the pulley downward in this direction with the T and T. So overall, the net force on this should be 2T. ये बेसिक बातें हैं, सबको पता होना चाहिए. The net force on this would be 2T. इसमें किसी को डाउट नहीं होना चाहिए. Though this pulley is not moving in this case, but in many cases the pulley would be moving. हम लोग उसके बारे में भी चर्चा करेंगे. We're going to talk about that as well. Let us write the FVD for this particular block. Let's suppose this is block A, this is your block B. Let us try and great. Now the mic is good. Let us try to write the FVD for A and B. For A, this is the block A. One force is acting downward, which is mg. One force is acting upward, tension, and here we'll be having the acceleration A. So T minus mg should be m into A, basic thing. Now for the block B, we'll be having some tension T upward. Now 2 mg downward, and that would bring an acceleration A. That means 2 mg minus the tension should be equals to 2 times of ma. As we can see, we have how many variables? We have tension as one variable and A as the another variables. So overall we have two variables and we have two equations. We can easily solve it. इसको हम आराम से बना सकते हैं बच्चों, मजे में कर सकते हैं. But the problem would come when we have more than two variables और two ही equations मेरे पास रहेंगे. I would be having just two equations, but the number of variables exceeds in the complex diagrams like this. This is a simple one, but we're going to have more complex diagram having such pulleys and the blocks. In that case, the number of variables would become more than the number of equations. Us cases में we use the concept of constraint motion. We're going to use the concept of constraint motion. So today I'm going to discuss about the constraint motion. मैं उसके बारे में चर्चा करूंगा. But for some people who has not been the part of the classes before, I'm going to give you 2-3 examples of easy types, and then I'm going to go to the constraint motion. All good, Sanchit? Is that okay to you? Good. Okay, quickly note this easy one down. फटाफट लिख लो and solve for the value of a. I want the value of a using these two equations. मेरे को a का value दो जल्दी से. Everyone, give me the value of a in terms of the masses. In terms of the masses, give me the value of a. Come on, everyone. देखते हैं who does it fast. Meanwhile, I'm going to write a second question for all of you. फिलहाल के लिए इसका आंसर मेरे को दो जल्दी. Come on, everyone. Who will give me the answer? Who will give me the value of a? जल्दी करो करो करो. Harika, what is answer? Harika, what is answer? Anyone? And could you follow these basic things? You don't? And?
Yes, sir.
Okay. Try this out. I'm sure you must be getting some doubts because you were not present in the previous classes. I'm going to help you out it separately. I'm going to help you out over there. चलो मैं करता हूँ. You guys are pretty late. हरिका है क्लास में? हरिका, you there? Harika is not here? Yes, he is there. Okay. I cannot hear you, but ठीक है. So I do not care for the tension. Okay, मुझे tension नहीं चाहिए. I'm going to do what? I'm going to add 1 and 2. इसको add कर दो ना. Tension would get eliminated easily. So T minus mg is equals to ma. Let me add this one. Minus T plus 2 mg. That is going to be how much? 2 times of ma. The tension would be cancelled. We should be having what? Mg is equals to 3 times of ma. 3 times of ma. M would be cancelled. A would be how much? G upon 3. Simple था बच्चों. This was damn simple. What else? What else? खत्म है कहानी. Adi, all good? Clear? Sanchit, Hitesh, Shreya, okay with this? Cool. Now, quickly let's move to the question number 2. Let's move on to the question number 2. So let us do it together. अभी इसको साथ में करते हैं. Then we'll talk about more difficult questions. Let us do number 2 together. Okay, so let me erase this out. Okay, here it goes. Alright जी. देखो simple सा concept है इसमें. There gonna be a force which will try to pull this block downward. इसको नीचे की ओर लाएगा. This will pull it downward. Let's assume this block is going downward, then this is going to go upward. So the force which makes the motion possible, उसको बोलते हैं जी driving force. If the force on this is trying to take it this way along the plane, then that force would be called as the driving force. उसको हम लोग driving force बोलेंगे. इसका FBD बड़ा simple है. The first thing that should act on it is mg, downward, the weight. Here the mass is 2m, so it's going to be 2 mg downward. दिख रहा है ना सबको? स्क्रीन पे दिख रहा है? Hitesh, Sanchit, is it visible? Good. Now, a part of this force should act this way, and a part of this force should act this way. This is 30 degree. then this angle should be how much? 30 degree. How? 30 degree, this line and perpendicular line. So perpendicular to this line is this, perpendicular to this side is this. So whatever angle we have between these two, the same should be there. एक logic है, concept है, सीखना चाहो तो सीख लो. I'm going to repeat this again. Perpendicular to this and perpendicular to this will have the same angle what these two has. So this angle should be 30 degree बच्चों. So this should be how much? 2 mg sine 30 degree, and this is going to be 2 mg cos 30 degree, and there should be a normal reaction on this direction जिसका हमको अभी कोई काम नहीं है, because the block is not flying off. block उड़ नहीं रहा है तो उसका हमको कोई काम नहीं है. Let us, and there going to be one tension in the string. Since the same string is here and here, so the same tension should be here. इसमें भी कोई doubt नहीं होना चाहिए किसी को. And here we should be having what? mg downward. Let us say that entire block is going on this direction with an acceleration of, let's suppose, a. Then this should also go up with certain acceleration, that should be a. Correct है जी? क्या सही है? If it is coming down a, then this should also go with the same direction. क्या सही है बताओ? Is it correct? बहुत अच्छे. ओके, चलो इसको फटाफट नोट डाउन कर लो. नोट डाउन क्लियर क्विकली. नोट इट डाउन. नोट डाउन, नोट डाउन, कम ऑन, कम ऑन, कम ऑन, जल्दी. ठीक है. Now let's say this side, if I write the your all the Newton's forces equation of motion इसे लिखेंगे तो क्या मिलेगा अपने को? 2 mg sin 30 is 1/2 minus tension should be 2 times of m into a. This is going to be how much? mg minus tension should be 2 ma, equation 1. And if I talk about this thing, tension minus mg should be equals to ma, should be equals to ma. This is my second one. Now the same thing that what we have over here is how much? The same thing, we're going to solve it. Add kar do, just add these two. So that would give you what? 2. Acha, if you add this up, see what you're going to get. You are going to get 0 is equals to 3 ma. It means acceleration is what? 0. It means the bodies are not moving at all. Bodies move nahi kar raha hai. It is in state of equilibrium. It is in the state of equilibrium. It is in the state of equilibrium. लिख लो फटाफट. It is in the state of equilibrium. It is in the state of equilibrium. Okay, now let me show you one example from where we can bring the concept of constraint motion. Let me show you one example that would help us. That would help us. Okay. So in all these cases आपने देखा कि same string से in the single turn पे वो added है. But there are going to be a cases in which the single string could also be molded in such a way कि एक ही पुली पे string को 2 बार लगाया जा सकता है. मेरा कहने का मतलब है ऐसा एग्जांपल से थोड़ा समझो इसको. Let's suppose if I have something like this. If I have a pulley over here, let's suppose there is a block. इसको A मान लो. Now it is coming over here on this pulley. It's going down and back like this. ये वापस से ऊपर की ओर आ रहा है. And it is fixed with some ceiling or something. Let's say I have a pulley over here and it is connected to the mass. Let's suppose इसको मान लो B. Let's take that as B. These surfaces are smooth surface, so friction is 0. There is no friction as of now. अब ध्यान से देखना. Let's suppose there's a tension T here. So the same tension would be there because the string is same. Same tension should be here. String is same. This tension would pull the block A and there going to be acceleration. So let's suppose acceleration of the block A in this direction. Okay. Now here we have tension T. Here we have tension T. That means there should be a tension of 2T. Shreya, all good? There should be a tension of 2T. Shreya, all good? Shreya, you there? Okay. So as of now, this is the case. Okay. Now let us write the equations. Let us write the equation. So for this block, I should be getting what? T is equals to M. Let's suppose if I talk about MA as the mass of the block A into the acceleration of the block A. That's my first equation. Now let's talk about the second body. Now these two body will not have the same acceleration. Okay, let me make this point very clear to all of you. These two blocks will not have the same acceleration because इस पे tension अलग लग रहा है, इस पे tension अलग लग रहा है. These two blocks are not connected with the same string. It is connected with a different string. This string is like the blue one and this is the red one. It's a different string which is connected to this pulley, which itself is not in touch with this, you can say that, which is in touch with this string, and it is not just part of this, it is also the part of this string. So इसका acceleration और इसका acceleration बच्चों वो same नहीं होगा. ये बातें समझ में आ रही है राहुल? The acceleration of this block and this block will not be same. Rahul, tell me if it is clear with you. Cool. So what we can do, let's say its acceleration is some 8 times B, AB. Acceleration of the block B. Now guys, let us write the equation of this block. Now here we have the force MBG acting downward. 2T is here and we have a force, like acceleration AB in the downward direction. So I can say what? Mass of B into G minus 2 times of T is equals to mass of B into acceleration of the block B. So dekho, how many forces do we have? How many variables do we have? First of all, let us figure out. 1 variable, 2 variable, and then 3 variable. बच्चों, we have 3 variables. हमारे पास 3 variables हैं. But how many equations do we have? We just have 1 and 2. 2 equation मेरे पास हैं और variables कितने हैं? 3 variables हैं. Can we solve it, Sanchit? Can we solve it with these 2 variables?
Yes.
No, we cannot, Sanchit. We have 3 variables na? Tension, acceleration of the block A, acceleration of the block B, and we have only 2 equations. तो ये solve नहीं होगा. It cannot be solved. Now what to do? अब देखो, अगर मुझे acceleration of A and B में कुछ relation मिल जाए, then I believe this is going to be easy. ये काम हो जाएगा. Agree करते हो कि नहीं सब? And that would be brought from the constraint equation. Now, what is the meaning of constraint equation? What is a constraint relation? What is a constraint situation? वो हम समझेंगे. Heading डालो, constraint relationship. Write the heading. Constraint, CONSTRAINT. Constraint relation. Constraint relationship. Now constraint relationship, इसका definition लिखो. if the motion of write the definition, लिखो फटाफट. if the motion of two or more than 2 blocks, if the motion of 2 or more than 2 blocks are, if the motion of 2 or more blocks are interconnected with each other, are interconnected with each other, then the relationship between the motion variables Now what are the variables of motion? Velocity, displacement and acceleration. These are the three variables, parameters of motion. मैंने स्टार्टिंग्स में ही काइनेटिक्स में बताया था आप लोग को. Then the relationship between the motion variables, variables is called as constraint relation. Is called as constraint relation. So basically, while writing the Newton laws of equations or Newton equations of motion, sometimes the variable becomes more than the equations, and in these situations the constraint would provide us extra relation which will help me to get the values of these variable. इसलिए हम लोग constraint motion को बच्चों पढ़ते हैं. That is the only reason why we study the constraint relation. Okay. तो देखो, there are few constraints that is there in your syllabus जो हमको पढ़ना है. पहला constraint है rod constraint. The first constraint that you need to study is the rod constraint. Rod constraint. Second जो हमको पढ़ना है उसको बोलते हैं string constraint. And third जो पढ़ना है अपने को wedge constraint. Wedge constraint. And the motion which is happening under the constraint is called as constrained motion. Is called as a constrained motion. Constraint is a noun. है ना, वो constraint noun होता है. Constraint means उस पे already constraint आ चुका है. That is called constrained motion. So these are the three types of constraint relations we have to study for your under your syllabus. तो पहला चलते हैं rod constraint पे बातें करते हैं. Let us talk about the rod constraint. Point number 1. फटाफट लिखो. If anyone has any doubt, do not hesitate in asking. Okay. Rod constraint. ध्यान से समझना, बहुत इंपॉर्टेंट है ये सब चीज. थोड़े थोड़े समझना, तभी जाके आगे क्वेश्चन सॉल्व होगा. Let's suppose I have a rod. I have a rod. Now, this rod can move in any direction. ऐसे वैसे ऊपर नीचे कैसे भी मूव कर सकता है. Even this part of the rod can move in any of the direction. कैसे भी मूव कर सकता है. Let us say बच्चों एक पॉइंट यहां पे A मान लो. Let's say पॉइंट B मान लो. Let's say the point B. Now अगर हम चाहें, या फिर इसको ऐसे एग्जांपल देते, अगर हम चाहें कि इस रॉड को ऐसे घुमा दें ना, ऐसे, इसको ऐसे भी कर सकते हैं, इसको ऐसे भी कर सकते हैं, और इट कुड बी लाइक दिस ऑल्सो, कैसे भी. तो लेट्स से इसका कुछ वेलोसिटी इस तरफ मान लो v ऑफ द पॉइंट A, और इसका कुछ मान लो ऐसे v पॉइंट B. मतलब कि आई एम ट्राइंग टू टिक रोटेट लाइक दिस, एंड दिस इज द लाइन जॉइनिंग दीज टू पॉइंट्स, ऐसे. एक वन क्वेश्चन टू ऑल ऑफ यू. राहुल, if I rotate this or make it any kind of motion, do you think that the distance between point A and point B would change? Will the distance of point A and B change, Rahul? No. If I make it move like this, will the distance change between this, Sanchit? Point A and point B? Sanchit, if I have this marker, if I make it move like this, will the distance between this blue tip, a strip and this part, will this change or not? Is it changing? And no. It means, let's suppose it is making some angle theta over here. This is going to be VB cos theta, and let's suppose this is some alpha. So this is going to be VA cos of alpha. In this case, let's suppose VB is more, then difference of these two will call as what? Velocity of separation. याद है ना? Velocity of approach and velocity of separation I have taught you guys. In this case, the velocity of separation would be 0. If suppose there would have been a velocity of approach होता इस तरफ से, तो velocity of approach भी 0 होता. So one thing has become very, very clear now. लिखो, write it down. The velocity of approach or separation along the length of the rod, along the length is 0. Make a note, everyone. Velocity of approach or separation. Velocity of approach or separation. Velocity of approach or separation along the length of the rod. Along the length of the rod would be 0. Velocity of approach or separation along the length of the rod would be 0. Along the length of the rod would be 0. Velocity of approach or separation along the length would be 0. Point number 2. Distance between the point A and B, the distance between the point A and B would remain same. Distance of the point A and B would remain same. The distance of the point A and B would remain same. And the third point, important point, third point, velocity of any point, be it A, B, C, D, E, F, whatever, velocity of any point along the rod, along the length लिख लो, velocity of any point along the length would be same. Would be same. Velocity of all the points along the length will be same. सेम नहीं होगा तो देखो क्या होगा, अगर सपोज कि इसको रख लूं मैं इधर, इफ लेट्स सपोज दिस इज अ मार्कर एंड इट इज मूविंग, इट इज मूविंग, सपोज ये जो रेड कैप है इसमें कुछ खास एनर्जी आ गई, इसने बॉर्नविटा या कॉम्प्लेन डी पी लिया एंड इट वांटेड टू मूव एट अ हायर स्पीड, क्या होगा, टूट जाएगा, इट विल ब्रेक डाउन, राइट? If all the points do not move with the same velocity along the length, it will break. ये रॉड टूट जाएगा. बातें क्लियर है हरिका? समझ में आ रही बात? Some issues with your sound, Harika, it seems. Swami, ये क्लियर है बच्चे?
Yes, sir.
Good. Rahul, Sanchit, Hitesh, where is he? Hitesh, Sanchit, could you just inform him where is he? He's still not. I know he has a doctor appointment, but he was supposed to be here. Okay. Anyways, so ये तीसरा पॉइंट हो गया, वेलोसिटी वुड बी सेम. एक क्वेश्चन करते हैं इस पे ना. लेट अस डू वन क्वेश्चन, इंपॉर्टेंट है, ध्यान से देखना. लेट्स से I have a rod which is kept like this. I have a rod which is kept like this. इसको थोड़ा ऐसे बना देते हैं. This is a rod. This is the rod stairs, जो बोलना आपको बोल दो, Let's suppose this is end A of the rod and this is end B of the rod. Let me check if it is coming in the frame. Yes, fantastic. Good. Now, let's suppose someone came and started pulling this at this end at a velocity, let's suppose VB. The bottom of the rod B is moving horizontally with the velocity VB. Is moving horizontally with the velocity VB, और इसका एंगल मान लो थीटा है जी बच्चों. This is your theta. ठीक है ना? So this would start coming down with a certain velocity. Let's suppose VA, VB, VA. Find relation between VA, VB and the theta. श्रेया बच्चे, ये बात समझ में आ रही है?
Yes, sir.
Good. Find a relation between VA, VB and the theta. कोशिश करो. You guys have 1 minute. जल्दी करो. And don't worry, I'm going to give you a break in some time. Break देंगे. But फिलहाल के लिए इसको करो फटाफट. Okay, anyone has got the answer? Anyone? Rahul?
Will velocity of V will A be equal to VB?
No, 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 no. Velocity will not be equal, na? It will not be equal. चलो करते हैं. Let's do it together, है ना? साथ में करते हैं. Let's do it together. We know that velocity of each point on the road along the length should be same. That's what we have studied so far. हमने अभी वही देखा कि velocity should be same along the length. Now over here, this velocity VB is not along the length. This velocity VA is not along the length. दोनों में से कोई velocity length के along बच्चों नहीं है. दिख रहा है ना? हाँ दिख रहा है. बहुत अच्छे. So first of all, everyone, you have to find the velocity along the length. ऐसे. Now, if it is theta, this also should be theta. है ना जी? And likewise, this should be how much? 90 minus theta. 90 minus theta. If it is VB, can I say this is gonna be VB cos of theta? Harika, your sound, your voice is not coming. Check your mic, please. है ना? And likewise, if it is VB cos theta, if it is VB cos theta, if it is VB cos theta, then the मेरी बात ध्यान से सुनना, everyone listen to me carefully. अच्छा मैंने इसको पहले ही बता देना था, but कोई नहीं. Now you should also understand that the velocity, the component of this velocity along this should be equal to this. Component of this velocity along this should be equal to this. इस बात को दिमाग में रखना. नोट कि इसका कंपोनेंट इस तरफ होगा, नहीं, हम उस पर चर्चा करेंगे. फिलहाल के लिए VA cos of 90 minus theta is the velocity along this rod. Is the velocity along that rod. इसको लिखो तो अच्छे से पहले. That is the velocity along that rod. That is the velocity along that rod. हम इसको और थोड़ा सा और बताते हैं आपको. बस एक मिनट रुक जाइए अभी. VA cos of 90 minus theta along this rod. Both of these should be same because the velocity of each point on the rod should be in the state in the same direction, or else it will break, and that should be equal also. That clearly tells me that VA cos 90 minus theta is what? Sin theta. VA sin theta should be equals to VB cos of theta. That means sin by cos tan, so tan theta is going to be equals to VB upon VA. बड़ा सिंपल सा रिलेशन आ गया VA, VB and V थीटा के बीच में बच्चों. राहुल, इज इट क्लियर नाउ? क्लियर है? इसके बारे में और भी चर्चा करेंगे. वी कैन डिस्कस मोर अबाउट दिस. संचित बॉय, आर यू फाइंडिंग दीज थिंग्स अंडरस्टैंडेबल? इजी समझ में आ रहा है? गुड गुड गुड. सो द वेलोसिटी ऑफ ईच पॉइंट्स अलोंग द लेंथ दैट वुड रिमेन सेम. और यही कॉन्सेप्ट हमने यहाँ पे यूज करा और अपने को आंसर मिल गया जी. आई थिंक ये क्लियर है ना? ठीक है. चलो अब ना इस पे थोड़ा सा और चर्चा करेंगे, बट बिफोर दैट लेट अस टॉक अबाउट द स्ट्रिंग कॉन्स्टेंट. Constraint number 2, string constraint. Harika, still I have not heard anything from you. Are you able to understand these things? समझ में आ रहा है? Harika's voice is not coming. Harika, I think you should check something. Maybe your mic is off. Okay, she is rejoining. And समझ में आ रहा है? And are you able to follow these things?
Yes, sir.
Good, good. कोशिश करते रहो. And wherever you're getting some sort of issues, you keep that noted. I would definitely be helping on that. Okay, now let's talk about the string constant. Let's say I have a string which is moving in the circular path. एक string है, string means what? धागा, रस्सी, wire, जो भी बोलो आप ना. It is inextensible, unstretchable, massless. Okay. So let's suppose I made this string move in this direction. In ऐसा घुमा दिया हमने. ऐसा घूम रहा है चक्री, going, ऐसा घूम रहा है वो. ठीक है जी. A point A over here, a point B over here, a point C if I take over here, or maybe here also D, maybe here also E. The velocity of this point A, Rahul, that should be in this direction, that is VA. That is VA. That is VA. Velocity of this point should be along this way. Harika, is it you? Okay, left the meeting. Now velocity of this point should be how much? This. Rahul, are these all velocity tangential? क्या सभी tangential है राहुल? Good. तो एक बात तो मेरे को समझ में आ गया कि all the particles will have the tangential velocity if it is moving in the circular path. All the particle will be in the tangential, all the particles would have the tangential velocity. तो पॉइंट लिखो, पॉइंट नंबर 1, speed of all the point, speed, I'm talking about the magnitude, speed of all the points, speed of all the points, speed of all the points in tangential direction, speed of all the points in tangential direction will be equal. That's a constraint number 1. Speed of all the points in tangential direction should be equal. Should be equal. Let's say if I have a straight wire, and let's suppose this wire is moving along this direction with certain velocity v, then all the points on the string will also have the same velocity. Will also have the same velocity along the length. So constraint number 2 बच्चों लिखो. हाँ, एक बात, सिंपल सी बात बता रहा हूं, ये सभी स्ट्रेच्ड स्ट्रिंग के लिए बात है. अगर मैंने एक धागे को ऐसे रख दिया लाइक then this thing is not going to work out on that. ये सारे के सारे stretched and taut. मैंने स्टार्टिंग में बताया था what is the meaning of taut. Taut is something when the string is in tensed condition, सब में stretching है तभी उसको बोलते हैं taut. Tight string को बोलते हैं taut. Now this is all about the taut string. All the points on the stretched string will have the same velocity. All the points on the stretched string will have the same velocity. ये बहुत इंपॉर्टेंट कॉन्सेप्ट है, इस पे तो खतरनाक क्वेश्चन आएंगे आपको, ये आपको अच्छे से पता होना चाहिए. All the points on the stretched string will have the same velocity. All the points on the stretched string will have the same velocity. अब जो भी मैं बताने जा रहा हूं इसको ध्यान से सुनना आप लोग, बड़ा ही इंपॉर्टेंट पॉइंट है, इसको अच्छे से सुनना, इसको अच्छे से सुनना जी. एक सिंपल सा एग्जांपल दिखा रहा हूं, ऐसे बहुत एग्जांपल्स हैं इस पे और अच्छे अच्छे एग्जांपल्स आएंगे इस कंस्ट्रेंट पे. यही है आपका जो पढ़ना है, और उसके बाद विल बी हैविंग द वेज कंस्ट्रेंट, वो तो अलग बात है, उस पर देखेंगे. लेट्स सपोज बच्चों इट इज कनेक्टेड टू दिस like with a pulley over here, ऐसा पुली है एंड ऐसा है ना, ऐसा एक पुली लगा दिया हमने, और दिस पुली लेट मी कीप इट फिक्स्ड एज ऑफ नाउ. इसको मैंने एक पुली ऐसे फिक्स कर दिया और ये बच्चों ऐसा हो गया, एंड लेट्स से दिस इज कमिंग डाउन विद द वेलोसिटी u. इसका अपना कुछ एक मास है एंड द सरफेस इज स्मूथ. ड्यू टू दिस movement of the string with the velocity u along downward direction, there should be some velocity that should be imparted on this block. इसका कुछ velocity आएगा, वो मान के चलो कि आप v है, वो मानकर चलो कि v है. और बच्चों this angle I take you, I give you as theta. Now the question to you is find the relation between u and v, between u and v. कोशिश करो, ट्राई करो, मुझे आंसर दो, फिर हम इस पर बात करेंगे. लेट मी चेक. हरी, कैन यू हियर मी? हाँ, नाउ इवन आई कैन हियर यू. वेरी गुड, वेरी गुड. समझ में आ रहा है हरी? सबको समझ में आ रहा है आपको? बहुत अच्छा, बहुत अच्छा. चलो, इसका u और v का मुझे रिलेशन दो जी, ऑल ऑफ यू. गिव मी द रिलेशन बिटवीन u एंड v. तब तक मैं थोड़ा पानी वानी पी लूं. गिव मी द रिलेशन बिटवीन u एंड v. जल्दी से करके दिखाओ जी. गिव मी द रिलेशन बिटवीन u and v. Rahul, what is your answer? Okay, Sanchit? Sanchit, you there? Sanchit, your mic is okay. ठीक है, चलो कोई नहीं. अब मेरी बात सुनो. कहाँ गया डस्टर? अच्छा, इधर है. मेरी बात सुनो. श्रेया, बताओ क्या आंसर जी? श्रेया बच्चे, ओके, कोई नहीं, ठीक है, देखते हैं. लेट्स हैव अ लुक एट दिस. ओके, मेरी बात ध्यान से सुनना सब. एवरीवन लिसन टू मी केयरफुली. जस्ट थिंक ऑफ दिस पॉइंट. थिंक ऑफ दिस पर्टिकुलर पॉइंट. लेट्स से दिस इज कुछ भी मान लो, ये मान लो. When the string comes down, will this point move in this direction? हाँ या ना? Will this point move in this direction? नहीं, obviously ऊपर नहीं जाएगा. When you pull it down, all the points on this side of the string will be coming down for sure, no doubt about that. Now all the points over here, their relative motion with the block should be zero. A point और a block हमेशा साथ में रहेंगे. ऐसा तो नहीं कि डिटैच हो रहा है. The string and the block is not detaching. Let's suppose कि यहां आ गया. It has come here. It has come here. Let's assume this way. String is like this now. It's inclined to a different angle. Still, this point A would be attached to the block. They are not separating. पहली बात तो ये. It means this point and this block's relative motion along the string would be zero. पहला पॉइंट लिखो. relative motion हमने क्या बताया था सेकंड में? velocity of approach and velocity of separation along the line should be zero. That was the point number 2, Rahul, isn't it? Do you remember that? So since this point is attached to this block as well as the string, then इसका जो relative velocity होगा और relative motion जो भी बोलो along the string would be zero. So the relative motion of A along the string along the length is zero. It means बच्चों, जिस velocity से ये स्ट्रिंग चल रहा है इन दिस डायरेक्शन, भैया ये पॉइंट भी उसी वेलोसिटी से इस तरफ जा रहा होगा. मेरी बात ध्यान से सुनना. रिलेटिव वेलोसिटी, इस बात को तो समझो, प्रोसेस कर लो, आगे बहुत काम आने वाला है. ये जो पॉइंट ए है, दैट इज ऑन दिस ब्लॉक एज वेल एज ऑन दिस स्ट्रिंग. ये दोनों का कॉमन पॉइंट है. द मोमेंट यू पुल दिस साइड डाउनवर्ड, तो हाँ थोड़ा जाएगा इस तरफ और इस तरफ भी आएगा, है ना. इट विल बी लाइक दिस ऑल्सो, लाइक दिस ऑल्सो. बट इसका वेलोसिटी, इस पॉइंट ए का वेलोसिटी अलोंग दिस स्ट्रिंग, अच्छा कैमरा उधर है, मैं आप लोग को देख रहा हूं बट कोई नहीं. तो अलोंग दिस स्ट्रिंग वो जीरो होना चाहिए. द रिलेटिव वेलोसिटी ऑफ दिस पॉइंट अलोंग दिस स्ट्रिंग शुड बी जीरो. मानते हो कि नहीं ऑल ऑफ यू? यस, इट विल बी जीरो. अच्छी बात है. सो this velocity v will have two components. One would be along this, and one would be perpendicular to this, along this and perpendicular to this. So the velocity v along this, the component of the velocity v along this should be how much? V cos theta. The component of the velocity v along this should be how much? V cos theta. That clearly says बच्चों v cos theta should be equals to u. इस बात को थोड़ा ध्यान से समझो, ऐसा मत बोलना कि सर u if you write u cos theta as v, एक पूरा का पूरा गलत है. u cos theta means you are saying that the string is going with a u. ना, there is a some difference. The string is not straight. इसका vertical में कुछ और velocity, इस तरफ कुछ और velocity है, तो वो नहीं होगा इस तरफ. You getting my point? So इसका कंपोनेंट एक इस तरफ जाएगा, वो कंपोनेंट इसके बराबर होगा, क्योंकि स्ट्रिंग इनएक्सटेंसिबल है, वो सेम ही जा रहा है और बीच में टूट फुट नहीं रहा है. अच्छी बात है, वो टूट फुट नहीं रहा है. इट क्लियरली मीन्स v cos थीटा शुड बी इक्वल्स टू u. दूसरी बात जो आपको कंस्ट्रेंट में दिमाग में रखना चाहिए कि इसका जो लेंथ है, लेंथ ऑफ द स्ट्रिंग इज आल्सो नॉट चेंजिंग. हम उस पर भी चर्चा करेंगे अभी, बट इतना समझ लो, इस लेंथ ऑफ द स्ट्रिंग इज आल्सो नॉट चेंजिंग. इसका लेंथ भी चेंज नहीं करता है, वो एक कॉन्सेप्ट हम लोग यूज करेंगे. बट अभी इतना समझ लो, इस वेलोसिटी का कंपोनेंट अलोंग द स्ट्रिंग वुड बी सेम. हमने पढ़ा था अभी जस्ट कि ऑल द पॉइंट्स वेलोसिटी अलोंग द लेंथ ऑफ द स्ट्रिंग और द रॉड वुड रिमेन सेम. ये बात क्लियर है जी बच्चों? ये बात क्लियर है? तो आइडिया लिख लो, इसमें नोट लिख लो, लिखो ब्रेक द कंपोनेंट, ब्रेक द break the velocity of block, break the velocity of the block along the string, break the velocity of the block along the string. Okay, break the velocity of the block along the string, not the velocity of the string along the block, not the velocity of the string along the block, string along the block. ब्लॉक के वेलोसिटी को ब्रेक करना है, ना कि स्ट्रिंग के वेलोसिटी को ब्रेक करना है. इस बात को दिमाग में रख लो जी. स्ट्रिंग के वेलोसिटी को ब्रेक नहीं करना है. अच्छा, इसी पे एक और क्वेश्चन करके देखते हैं. आई एम श्योर आप लोगों को समझ में आएगा. राहुल क्लियर है जी बच्चे? राहुल, राहुल, इज इट क्लियर दिस पार्ट? गुड. तो इसको मैं थोड़ा दिख रहा है उस तरफ ना. Let me check if it is coming in the frame of hammer or not. Okay, it is coming, but very less. Okay, just a second. Adi, are you there?
Yes, sir.
Okay, good. Are you able to follow these things, Adi?
Yes, sir.
All right then. Okay, let me draw it this side. Okay, so let's say that there is a pulley and it's constrained over here. इसको fixed है. Let's suppose there is one block over here, and there is one more block that is connected with the string over here. Now let's say this is A, और इसको B मान लो, इसको A मान लो. Let's suppose this is the velocity VA in this direction, and here we have the velocity VB in this direction. एंड ठीक है ना, कुछ एंगल वेंगल ले लो, इसको ले लो थीटा बी एंड लेट्स से दिस इज थीटा ए, दिस इज द थीटा ए थीटा बी. Find the relation between VA, VB, VA and VB. Okay. Find the relation. Find the relation between VA and VB. Find the relation between VA and VB. Come on, करके दिखा. Find the relation between VA and VB. Find the relation between VA and VB. Find the relation between VA and VB. Who will give me the answer? Rahul, Sanchit, Harika, Anne, Shreya, Hitesh, Adi. Anyone? What is the relation between VA and VB? Come on. What is the relation between VA and VB? What is the relation between VA and VB? Okay, देखते हैं, करें इसको. सौमिका, साथ में करें.
Yes, sir.
ओके, सो क्या मैसेज लिख रहे हो जी आप लोग? आदित्य सर, आई थिंक द बोर्ड इज ब्लर. ओके, इज बोर्ड ब्लर फॉर एवरीवन? You can tell me. You can tell me. It's bit blurred, huh? Okay. Yes, I can see it's bit blur. Okay, so this meat is a problem. Okay, okay. Alright then, it's just not taking properly. अच्छा ठीक है, इसको मैं I would rectify this. दिख रहा है कि नहीं, मतलब काम चल रहा आदि, समझ में आ रहा है क्या लिख रहे हैं बोर्ड पे?
सर अभी तो थोड़ा ब्लर है.
हाँ ठीक है, ब्लर है, बट व्हाट आई एम सेइंग इज समझ में आ रहा है ना, दिख रहा है ना, मतलब.
हाँ दिख रहा है सर.
हरिका, you able to see the data, right? Okay. ठीक है, these are the experimental things going on. तो थोड़ा सा अच्छा देखो, बड़ा सिंपल है, इसमें कुछ मुश्किल नहीं है. हमेशा क्या करेंगे, along the length of the string हम लोग बात करेंगे जी. VA, if it is theta, इसको ऐसे रख लो, है ना, थोड़ा देखने में आसानी होगा. If it is theta, this angle should also be theta A. तो this velocity VA cos of theta A. बड़ा सिंपल है बच्चों. इसका देख लो, this is your theta B. So this component should be how much? VB cos of theta B. Rahul, velocity of each point along the string should be equal. It means VB cos of theta B, बच्चों, that should be equals to what? VA cos of theta A. खत्म कहानी. So this is the relation between the velocity of the strings and the of the velocity of the block with the angles theta A and theta B. एक ना HC वर्मा में एक बड़ा अच्छा क्वेश्चन है, वो करवा देता हूं, then I'm gonna give you break, है ना. एक क्वेश्चन करवाते हैं, अच्छा क्वेश्चन है, HC वर्मा में दे रखा है, एक ऐसे यहां पे बना लेते हैं. So let's suppose here we have a block, एक और पुली हमने रखा है ऐसे. So it is connected like this, अयो हाँ, ऐसा कुछ है ना, ऐसा, ठीक है. It is pulled from here, it is also pulled from here, है ना, ऐसा कुछ है. एंड यू ठीक है ना. अच्छा, इसको बांध देते ना, हाँ, इसको रख दो, बताए बोलेगा सर पुली गिर जाएगा सर. हाँ, टिक 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 टिक, इसको मान लो यू, इसको भी मान लो यू. अब बताओ, फाइंड द वेलोसिटी ऑफ, अच्छा एंगल देने दो, रुको. फाइंड द वेलोसिटी ऑफ द ब्लॉक, in terms of u. So find the velocity of the block in terms of u and the theta. Let's suppose I tell you that this angle is theta, this angle is theta, and this is going up with the velocity v. Find the relation between u and v. Find the relation between u and v. आपको दिमाग में क्या रखना है? You have to break the velocity of the block along the string. So component of the velocity of the block along the string should be done, not the velocity of the string along the block. जो मैंने बोला उसी को अप्लाई करो, within 30 seconds इसका आंसर दो. The velocities of the block should be broken along the component of the like along the string, not the string का component along the block of motion. The velocity of the block, the component of the velocity along the string. कितना हो गया जी? कितना हो गया जी? The component of the block's velocity along the string. Okay. So this is going with a v. This is going with v. This should be how much? V cos theta. I'm breaking the component of the velocity of the block along the string. V cos theta, and we know that along the string the velocity of each point should be same. That means v cos of theta is u. ये सही है, बट कुछ बदमाश नादान बच्चे क्या करते हैं, वो क्या कर देंगे, इसको u मान लेंगे और u cos theta is equals to, they would write u cos theta, और इस तरफ से भी u cos theta, तो they will say u cos theta plus u cos theta is equals to v. That is 2u cos theta is equals to v. अरे बच्चों ये हो गया गलत. स्ट्रिंग का कंपोनेंट ब्रेक नहीं करना है, ब्लॉक का कंपोनेंट ब्रेक करना है along the string. ये बातें दिमाग में सबको होनी चाहिए. So this is the correct answer. V cos theta should be u. कोई दिक्कत? राहुल क्लियर है जी बच्चे? एक सिंपल सा क्वेश्चन बट अच्छा क्वेश्चन है. इट्स वी ऑलवेज गिव्स अ गुड क्वेश्चन. हम इससे बढ़वा के कुछ और भी क्वेश्चंस करेंगे. कंटिन्यू करना चाहते हो ब्रेक लेकर कि आज के लिए बहुत है?
Sir, that should be same all over, right?
Yes, yes, always same. Always. Blocks component along the string. Is that your question, Harika?
Yes, sir.
हमेशा इस रूल को, because I have told you 3 points in the string constraint. Motion of all the points on the string along the length would remain same. Point number 2, the speed will be tangential, है ना, and they would be equal. It means speed along the tangential path should be equal. ये point number 2 था, है ना जी. और थर्ड जो हमने पढ़ा इसमें केस में कि the relative velocity of the points on the string along the length would be 0. Whether the relative velocity could be velocity of separation or velocity of approach, वो 0 होगा, वरना क्या होगा, टूट जाएगा ना. सिंपल सोचो ना, इस पॉइंट का वेलोसिटी और इस पॉइंट का वेलोसिटी अगर एक मूव कर रहा है वो सेम ना हो तो इसको टूटना होगा. इट हैज टू ब्रेक डाउन. मेरे हाथ का इस पॉइंट का वेलोसिटी कुछ और है, इसका वेलोसिटी कुछ और है. इट हैज टू ब्रेक इन ऑर्डर टू मेंटेन द डिफरेंट वेलोसिटी. क्लियर है ना हरिका? ऑल गुड?
The instantaneous velocity is 0.
When it breaks, come again. Instantaneous velocity. नहीं. When it breaks, let's suppose it is already moving, है ना? It's already moving, right? और उस केस में ब्रेक करता है, like for example, a fighter plane मूव कर रहा है ना, और मूव करते वक्त वो बुलेट शूट करता है. इट मींस बुलेट इज स्प्लिटिंग फ्रॉम द फाइटर प्लेन्स का गन बैरल्स, है ना. इसका मतलब नहीं कि उसका वेलोसिटी 0 बचे ना. इट इज थ्रोन, इट इज गिवन विद अ सर्टेन एक्सेलरेशन उस केस में. अब लेट्स सपोज कि आई एम मूविंग लाइक दिस, यू नो, और एक प्लेन से जा रहे हैं, उसमें स्टोन हमने गिरा दिया टपक. इट इज ऑल्सो केस ऑफ सेपरेशन, है ना, बट उसका स्टोन का वेलोसिटी 0 नहीं होगा. दैट विल इनिशियली हैव द वेलोसिटी ऑफ द प्लेन फ्रॉम विच इट वाज ड्रॉप्ड. करेक्ट है ना? हमने बता रखा है कि किसी भी बॉडी को जब आप सेपरेट करते हो, द वेलोसिटी ऑफ द मूविंग ऑब्जेक्ट वुड बी ट्रांसफर्ड टू द, और यू कैन से ट्रांसमिटेड टू द डिस्टैच और डिटैच्ड ऑब्जेक्ट. हाँ, उसका एक्सेलरेशन नहीं जाता है. दैट्स द रीजन ना, व्हेन यू मूविंग इन अ ट्रेन, आप कुछ ड्रॉप करते हो, इट डज नॉट गो वर्टिकली, वो ऐसे जाएगा डूइंग, बिकॉज इसके पास इनिशियल वेलोसिटी होता है। हरिका, ऑल क्लियर? एनी अदर डाउट्स, एनीवन? एनी अदर डाउट्स? ओके जी, बढ़िया। तो एक काम करते हैं, लेट्स स्टॉप फॉर अ ब्रेक नाउ एंड शैल वी